Let's see. So anyway, so I just want to quickly, as I was touching on before, most of the power here is natural gas, and we just want to talk a little bit about the risk mitigation here. APS, the red, is 80% all natural gas as we understand it. The dark blue from NVE, this is from OPD's own projections, and the purple, which is the Glen Canyon, is also partly natural gas already. It's about 20% natural gas because they don't have enough hydropower to fulfill the firm power requirements. You can look it up in their filings. So you're already buying natural gas through some of your hydro, and Hoover's disappearing slowly because of the 5% curtailment. And
however, by the way, we don't get any of that natural gas from the hydro project. That's for the retail customers. So.
For the firm, to deliver firm, they have to be. They're buying 25.
No, our delivery is by.
It's only by hydro.
100% hydro.
Well, even so,
even though our power comes directly from Reed Gardner or Switchyard, it's not considered coal power. There's no coal allocation.
But you're buying from Arizona Power, who's delivering it through that junction. Anyway, so the solar will provide diversification. It would give you about, depending on how much you buy, perhaps 20%, which would keep you from the issues of what happens in natural gas prices, which are historically low right now, go up. And we're not talking about next year. We're talking about over the next decade to 2 decades. There's already issues about whether shale, how long it will remain at $4. It will keep it down at $4. But if you look out at what a natural gas plant gets built for today, the marginal cost is $40. That's where people buy the power and do their O&M. But the actual plant itself is 60 to 65. So we're pricing in the neighborhood of where someone would build a natural gas plant. We don't have the control. We'll admit that. We don't have the control what they do. But we also don't have any of the upside. Natural gas goes to 10, and it's been there. The price doesn't go up. It's frozen, and the price stays there. And you can remember, meat power prices were 120. Within the past decade.
So, do we have any mandates from the government or state that say we have to have so much solar by a certain year?
There is a state mandate, but it only applies to the investor-owned utilities, and there's only one, which is NV Energy. So they're the only one under the mandate.
Yeah, you're not required, and not actually. But notice that APS, they have their own planning document. They anticipate 582 in their reference case for natural gas in 2020. That's their estimate, and remember, that's delivered to them. That's not at the futures price. And that would imply roughly a marginal price of $53, even before losses, delivery, transmission, and their own cost of capital. So, they're not looking at selling their power to you much less than 60 or mid-60s, even when they come up with the next contract if you ask them today. We'll obviously, 4 or 5 years, things may change. So anyway, the basic overview of the project. There are 4 major things that go into how a project gets priced and built. Technology and construction are relatively commodity-like. There's high competition, and people are getting more efficient in both those categories. What really matters and what you can control is the location of the financing. It depends on how close it is to the lines, how flat the land is, how easy it is to build on, and the financing. You have, as I said, preferred financing, but you also have, before 2016, the ability through us to take, and through a project, to take advantage of the tax credit. And that's important. So that's what, as a developer, that's what you have control over, is the location of the financing. Well, we've worked closely with a very large electrical engineering firm to serve as EPC. They would build a turnkey. They have priced it, given us a firm bid.
You might share with them what EPC is.
Engineering, procurement, and construction. They would basically, from start to finish, they would start the grading and turn it over to us when it had been fully tested. And so we would not personally be building, but it would be someone who's already built several projects of this size in Nevada and is relatively large. But there are other ones that could step in if for some reason that EPC was not acceptable to Origin or for some other reason. That is, as I said, the construction is a relatively, not completely, but a relatively commodity project. We think that we've been working closely with them, and hopefully we will be able to continue that. We've identified pre-construction requirements. We don't think there are any major roadblocks whatsoever. What we really need is the design specifications to figure out with the PPA what Overton Power needs, and if there are any issues that we need to deal with that are just invisible to us because of they're deep inside the system somehow. Note that this facility could be built in about 6 to 8 months from once physical construction actually started. It's not something that has huge construction. We're not building a big tower. We're not building a 600-foot tower. It's not something that's gonna take 3 or 4 years. This is something once construction's ready to go.
You've already explored your permits with Park County? Because
Well,
I've never seen anything built in Park County in 6 to 8 months.
It's actually in Lincoln County.
No, it's in Lincoln County. Well, you're probably in good shape there. You might be able to get it built.
They're, as we understand it, anxious to see.
Yeah.
So the basic design, and like I said, we're not building some one-off big, you know, if you've seen Ivanpah out on the California and Nevada border, it's amazing. It really is amazing, but it's not standard, and it's not necessarily cheap either.
$2.5 billion.
What?
It's $2.5 billion.
And growing.
Yeah.
But it's still not done. So they've been going at it for 3-something years now, 3.5 years now. This would be typical flat panel photovoltaic. So you see them on rooftops, on people's houses. You know, they're the standard product. They're basically 6 feet by 3 feet. It's very human scale, and it's very modular. So if one part of it were to break, it's that one part that breaks, and we go and fix it. But you know, there's going to be a lot of panels, and something may break. We may have, but you know, SunPower, as an example, of a manufacturer claims that their return rate is 0.0027%. So you know, the return, they don't have, it doesn't happen often. This is not, the panels have no moving parts. It's simply the laws of physics, and the physics that was discovered 100+ years ago and been implemented for more than 40 years. Central inverters or microinverters, depending on which is labor saving and even more modular, convert the DC power to AC power. This is the basic, the panels produce DC, and they need to be put up to AC to be able to be delivered to your lines. There'll be step-up transformers within a substation and all the other breakers and related equipment that's necessary, and then a couple miles of transmission line to get it to a bus at OPD's lines running across the mesa, and then operations and monitoring equipment to make sure it runs smoothly. Final purchase order is not for 2 years. Yes?
One more question on the...
I'm going to go back to the tracking.
Yeah, the tracking system.
I'll go back to the one.
Oh, okay.
We're not going to decide on everything today because technology keeps changing. The new generation of panels, the new generation gets simpler, it gets more efficient. They'll be chosen in 2015, late 2015. But you know, everything is going to be, it's a design low to the ground, easy to operate, easy to maintain. So back to the tracking. Sorry, I'll go with that. One of the ways that we get to this price is by putting in a tracking system, which is a little less than 10% more cost, but gives you 20% to 30% more production net of any consumption that it uses, which is very small. It moves the panels around, so single axis tracking moves it east to west to follow it during the day. Dual axis moves it also so it follows it during the seasons a little bit better. Nothing's perfect. It's not, you know, at some point during the day, the sun's so far down below the horizon you just can't track it. But what it does is it gives you a lot more power for a little bit more investment. And these are systems that have been tested. These are systems that they're small motors. It's not like there's a huge motor because we're building it at a very small scale. It is like the size of a motor that you have in your lawnmower. It's not a major thing. It's easy to maintain. It's a small increase in investment. We already have to have people watching over this, obviously. Dealing with, you know, an hour here, an hour there is not a big deal during the year, and there are obviously technicians who can come out if it turns out to be something more complicated. But it's distributed as well. It's not one big motor. There are going to be lots of motors. On the dual axis, we think there's going to be about 100. On the single axis, probably a similar number, maybe a little bit more. So it's not as though there's one single motor that if it breaks, everything's sort of frozen in place. But even in that case, during the time when it takes to fix the motor, the solar panels are still going to work. That's not necessary to be pointing exactly in the right direction to make it.